Hey there, everyone. Brian Schul, Straight Data Science. So today I have a very interesting topic that I want to introduce you to. This is how to use graph-based models to detect fraud, and we're use Python and Jupyter Notebooks, of course. Okay, I use Jupyter Notebooks for all of my instructional videos here, and this is a very important topic for fraud detection, right? Because people can um, pass money between banks, use different accounts, different transactions, pass money to different people. They can pass money to other people and then launder that money through a bank or do commit some type of fraudulent activity, right? So using a graph-based model to reveal or uncover these relationships really makes a big difference, right? Because we want to understand the relationships and how this whole interaction evolves and all the money moves around. It's very, very complex, but that's why you need this type of graph-based modeling methodology to uncover these fraudulent rings, right? Or this money laundering or fraudulent activities, right? There's a lot of anomalies that are structural, right? That we can determine just with columns and rows, and this it looks kind of like an Excel spreadsheet or like a table in a database, right? And that's fine. That's structured data, but sometimes with these fraudulent activities, it gets so complicated you can't just determine that, or you can't uncover that the fraud using a structured formatted data set, right? So we are going to break this apart and look at this almost like a Facebook account or like a LinkedIn account where you have your own account, right? And then you have your friends, and then your friends have their friends, and then their friends' friends have their friends, and then their friends' friends have their friends, right? That's how money laundering typically works. It's all this stuff scattered all over the place. It gets very complicated very quickly. We need some type of really advanced methodology to determine how this fraud is occurring and how to prevent it from occurring in the future, right? So that's what I want to take you through today. It gets very complicated, but with this kind of technology that I'm going to show you today, it actually simplifies everything and it makes a whole lot more sense, right? So we have to get away, and just from the time being, I'm not saying forever, but just from the time being, get away from these Excel spreadsheets where you have columns and rows, or you have a structured database, again, with a table that has columns and rows. Let's ignore all that for the next 10 minutes or so and just understand everything from a broad perspective, how everything can happen, okay? Almost how the wind blows. The wind can blow in all kinds of different directions, right? And you can't really predict that. You can't really anticipate that. But graph-based modeling can help us understand the complexities of these systems, right? So let's jump into it. So I have the code here, and I'll share all this code with you guys. With all my videos I do, I always write up the code, test it, debug it, make sure everything works, and then I do the whole narrative. That's what I'm doing right now. This is what I call a narrative, and then I share the code with you too. So the code has been tested and proven to work. So let's create just a simple data frame. All you need is a few columns of data here, and again, we're gonna kind of like set up the columns and rows of data, but understand the whole framework here from a very, very different perspective, from a very disconnected or very relationship oriented kind of perspective, right? So we have a sender and a receiver, the amount of the transaction, and the timestamp. And you can have other features in your data set, and that's totally fine. But these are the ones that we're going to focus on right now. Okay, so I'm going to go ahead and run the code, Control Enter to run it. Okay, so give it a second to finish off here. Okay, so we have the sender receiver, the amount, and the timestamp, and we're going to use this as our simulated hypothetical fraudulent data set. Okay, so I don't have actual raw data because that's proprietary. I used to work for a whole bunch of banks. I don't work for any bank now, and even if I did, I can't share that proprietary data with you, right? Can't put that into the public domain, but we can create something that's synthetic but realistic, and this will simulate actual fraud data. So we have this right here, sender, receiver, amount, timestamp, okay, and then we are creating the day from the timestamp, so we're getting the date, Okay, and this is very common. This is called feature engineering. This is very simple feature engineering. We're just taking a basic timestamp and creating a date. You can create days of the week, times of the day, um, months, years, and so on and so forth, right? There's all kinds of time metrics that you can create. So I just displayed the data. This is what it looks like right here, okay? So here's all the details. It's pretty extensive, okay? So based on that, I want to go ahead and create my first network graph right here. So I'm going to import the network as NX. We always import this. I have several other videos about graph analysis. You can check that out on my channel. So I'm going to create that and then use these features right here. So the source is going to be the sender, the target is the receiver. Hopefully that makes sense. The edge is going to be the amount and the timestamp. So the graph has 1,000 nodes and 4,969 edges. So what does that even mean, right? What does this stuff mean? So a node is basically a point or an entity in the network, and an edge is a connection or relationship between the nodes, okay? So an example, a real world example would be a node could be a bank account or a customer, like an actual entity, a physical entity, and an edge could be a wire transfer between the accounts. Or a node could be a user, okay, that's a physical person, and the edge can be a friendship or a message, okay? So the edge is more the concept or maybe the transaction, and the node is like a physical entity or being or some type of person or a maybe even a building. It could be a bank. It could be a building. That could be a node. Okay. So let me go down here, refresh this, and we're looking for all of the within that graph network. We're looking for all of the sender receivers and the rings, and we're going to append this into a list. So in the Python world, anything with a square bracket is a list. If it has curly brackets, that is a tuple, right? And a dictionary is another column, another common item that you'll see in the Python world. Dictionary. It has keys and values, so it's a key value pair, and you'll see a lot of data frames too. So I'm going to create a list. A list is just a structured, basically just a big list that we can take things we can append to the list. So that's what we're doing: the sender, receiver, the amount, the timestamp, and then the day. That's the feature engineering character that we created before. So now I want to go ahead and run this code right here, and again we're taking everything, putting everything, all the fraud transactions into a list. That's what this square brackets is for. So we're taking everything that has to do with fraud. We're trying to determine, is this a fraudulent activity or a legitimate activity, right? If it's legit, we want to let go. If it's fraud, we want to intercept it, right? And there's like 4 different potential outcomes. You can have a true positive, a true negative. A true positive is a transaction is fine, we let go. A true negative is a fraud activity and we capture it. You could also have a false positive and a false negative. A false positive would be there's a fraudulent activity and we intercept it, but it's not real fraud, right? So it causes the compliance team to do a lot of work and they get worked up about that, and it causes a lot of frustration, but it's not a real actual fraud activity. And we can have a false negative, which is actual fraud, and it never gets detected, right? And that's what costs these businesses a lot of money. So you can lose millions of dollars, right, when you have these transactions that go through that aren't detected as fraud, but it's real fraud, and you can lose your reputation. There's reputational risk, there's compliance risk, there's all kinds of different risks around this, right? So we want to detect the um, false negatives, right? So or false positives, false positives. So it's a positive fraud, but it's false because we didn't detect that. So that's the goal here. So let me go down here and we're going to create one more data set. So I'm just introducing the topic. Hopefully all this stuff makes sense. Just think about it a little bit, mull over it for a little time. Hopefully that will digest in your system and that makes sense eventually. So again, we're going to look at the sender, the receiver, the amount, and the timestamp. Okay, and again, I don't have proprietary data, and even if I did, I couldn't share it with you. But I'm going to run this and create my first graph-based network model and then actually illustrate the model. Okay, so if I zoom in, this is what the model looks like. And we have the user and then all the connections. So if I move this around, it's very dynamic and interactive. It looks like, almost like a biological, what is it called, bacteria or fungus or something, maybe moving around. You can't really see bacteria and fungus, right? But if you zoom in with a electron microscope, you can, right? So to me, that's what this kind of looks like a little bit. So it's very interactive, very dynamic. And this shows us graphically all the connections in this whole network. And you can see it's very complicated, right? That's why I said originally, like you have this whole, all these Facebook connections, all this LinkedIn connections, right? But how does this look visually? This is actually how it looks visually. These are all the connections, right? But is this really helping me determine what's fraud? I'm not too sure. I see a lot of users and a lot of connections, and it is illustrative and it is helpful. But does this help me determine the fraud? No, not really. So this is my first attempt. I'm just showing you what I did to try to get this model working. So I looked at that and I thought, okay, that's pretty close, but it needs to level up a little bit, right? Because I can't tell what's fraud here and what's not fraud. So I have to go another level up, right? I have to get more sophisticated here. So I'm going to make another attempt, reanalyze the data, and then try to determine now all these network interactions and all these relationships and what's fraud here, okay? So now when I zoom in, I see what I saw before, okay? I see the different users, different transactions. These are all the connections. This is a network graph. And now I can finally see the fraud, right? So the fraud is in red and the green is in, the green is good. So almost like the stock market, like green is good, red is bad, right? You want your stock to go up. If it's up, it's green. If it's down, it's bad. So now we can isolate the fraud and we can see the connections here. So there's one good connected with this fraud ring, but all these other guys are basically passing all this money around. Oh, there's actually three. So one, two, and three. So this is a perfect example here. This is all fraud. Everything in red is fraud. And they're passing this off to a green. So the green is good. So that's going outside of the system here and getting transferred to some type of bank account or money institution, who knows, some kind of investment account or something like that, right? So you're taking all this fraudulent activity. You can see the ring here in red. All these guys, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 fraudulent activities, and they're going outside of the network, right? Outside of the group or the crew here, the fraud crew, and they're getting 3 good transactions, right? So they're laundering money and they're getting it into the financial system, right? So, and that's how I did. If edge color is red, is fraud, otherwise green. But I still need a little more details. Like this is very helpful, okay? This graph was good, but I can't tell what's fraud. All I see is the network connections and the graph, right? Here I can tell the fraud ring. I can see the whole crew that's creating all this fraud, right? And they have 3 associates or 3 partners here that are taking the money outside of the fraud ring and introducing it to the broader financial system, right? So that is great, but I need a little more detail, like what's actually happening here behind the scenes. So again, I level this up and try to get more details here just so I can see, okay, I know the fraud, I know the transactions that are occurring here, but I need a little more details here in this system so I can see the amount of the transaction too. So you can see here this 21,000, 19,999, 999, and so on and so forth. So you have these 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 again, just like we saw before, and 3 going outside of the fraud ring. So probably, typically, like if you go to a bank, I think the threshold for a bank reporting this to, what is it, the Federal Reserve, the IRS or something, whatever. Like if you deposit more than 10,000, I think the bank flags it and just says, okay, more than 10,000 came into this account. If it's under 10,000, then the bank does nothing, right? Because it's called de minimis. It's so small, it doesn't really matter, right? Over 10,000, it matters. Under 10,000, it doesn't get flagged because it doesn't matter. It's too small. So I think in this example, it's around 20,000. Again, kind of hypothetical data set that I came up with. It's not real data, but it is very realistic and very representative of what you'll see in the real world, right? So this whole fraud ring passes around this 20K, and then you get 489.50 out of the fraud ring, 248 out of the fraud ring, 1,263 out of the fraud ring. And again, the bank isn't going to flag this because it's under 10,000, right? Over 10,000, then the bank says, okay, we have to send a message. Under 10,000 doesn't matter, it's de minimis, right? So this is how the fraud works. So they pass it around to a bunch of different associates or partners or whatever. Then it goes outside of the network, outside of the crew, and it gets redistributed in the broader financial system, right? So that's what we have to look out for. That's what we have to prevent. And to use a column and row system, it's just not going to cut it. It's not sophisticated enough to detect these very nuanced transactions you'll see in the financial world, right? You need something like a graph-based model to help you understand the relationships of this bigger system that's very complex and very interactive and very dynamic, right? But with a graph-based model, we can do that quite easily and uncover and expose all the fraud here that's going on and then prevent it from happening again. But these guys are very clever and they're tricky and they're cunning. These guys are very cunning too. So you can expose one fraud ring and these guys will come up with a alternate way to try to beat the system. And then you discover that and they'll come up with another angle, right? Another perspective on things and try to beat the system again. They're very cunning and they're very tricky, right? So you always have to try to stay one step ahead, and a graph-based model is a good way to expose the deviance that's occurring here, and then try to intercept it and try to reveal it and prevent it from happening again. So that's it. I'm going to wrap it up here. Kind of a short video. And that's how we can use graph-based modeling to detect fraud in our financial systems. So thanks for tuning in. Hopefully that was educational and somewhat informative. I try to drop knowledge wherever I can, and hopefully this was a good one. Okay, so thanks for your time today, and I'll see you guys in the next video. Bye.